Hello students, today we will do the next part of dynamics. So today we will study Newton's second law of motion. Now to understand Newton's second law, let us consider a situation in which suppose there is a particle or an object that is of mass m. This object is of mass m and we are applying a force to it, applying an unbalanced force to this object. Now what will be the result? We have already seen if an unbalanced force acts on the object, it will accelerate the object. So according to Newton's second law, a force that accelerates an object, that is nothing but the unbalanced force, is equal to the product of the mass of the object and the acceleration produced in the object. That means this unbalanced force that is acting on the object and that is accelerating the object is equal to the product of the mass of the object and the acceleration that is produced in this object. Now, as you know, the force is measured in Newton. So how will you define 1 Newton of force? 1 Newton of force is the force that accelerates a mass of 1 kg at a rate of 1 meter per second square. That means what? If mass is 1 kg and the acceleration is 1 meter per second square, then the force will be mass is 1, acceleration is 1, and this force will call it as 1 Newton of force. That means in this equation F is equal to ma. When m is 1 kg, acceleration is 1 meter per second square, then the force will be 1 Newton. That is the definition of 1 Newton of force. Now, suppose a particle or an object is falling vertically downwards. This object is of mass m kg. It is falling downwards. So, which force is going to act on this object? That is nothing but the force of gravity. So, the force of gravity that acts on an object of mass m kg. It's called, what it is called? The weight of the object. Now, if you neglect the air resistance, then this object is going to accelerate downwards at a constant rate. And this rate is g, and that is equal to 9.8 meter per second square. And that is called as the acceleration of free fall. So if you neglect the air resistance, any object will accelerate downwards at the same rate, and that is 9.8 meter per second square, which is called as the acceleration due to gravity or acceleration of free fall. Now, according to Newton's second law, F is equal to ma. So if you consider the vertical motion, then the force acting on this object, or the resultant force that acts on the object that is accelerating this object downwards, is the weight of the object. That means F, I will replace it by W, because that is the resultant force. M, and A is what? G. G is the acceleration of free fall, or the acceleration due to gravity. So G is 9.8 meter per second square. Now take for example an object of mass 1 kg. What will be its weight? Weight of an object of mass 1 kg will be W is equal to 1 into G is 9.8. That means its weight will be 9.8 Newton. 1 kg is the mass and the weight is 9.8 Newton. So, let us see some of the problems on this concept. So, the first question here. So, let us consider an object a force diagram is given to you. This object is of mass 5 kg. On this object, different forces are acting. So a force of x Newton is acting towards the right. A force of 4 Newton is acting towards the left. A force of y Newton is acting vertically upwards. And obviously, how much force will act vertically downwards? Because the mass of the object is 5 kg, its weight, that is 5g, will act downwards. Now it is given that this object is accelerating towards the right, and the object is accelerating at a rate of 3 meter per second square. So you have to find x and y. Okay, now let us consider the vertical motion as well as the horizontal motion. Now vertically, there is no acceleration. That means vertically the object is in equilibrium. Vertically, the object is in the equilibrium. Why? Because vertically it is not accelerating. That means vertically the forces are balanced. The resultant force is 0. That means y will be balanced by 5g. That means y is equal to 5g Newton. Okay, 5g Newton is acting vertically upward, 5g acting vertically downward. So the resultant force vertically is 0 Newton. That means no resultant force is acting vertically. So the particle or the object is not accelerating vertically. Now let us consider the horizontal direction. Now we have already seen that the object will accelerate in the direction of the resultant force. Now since the object is accelerating towards the right, that means the resultant force is acting towards right. That means x Newton, that is acting towards the right, will be greater than 4 Newton, because we have already seen that the resultant force will always act in the direction of the greater force. So horizontally, what will be the resultant force? X towards the right minus 4 towards the left, and that should be equal to the mass of the object into the acceleration, Newton's second law. So x minus 4 should be equal to 5 into 3. Is this concept clear to you? So if the acceleration is towards the right, that means the resultant force is acting towards the right. So the force towards the right direction should be greater than the force towards the left direction. So the resultant will be the force towards right minus force towards the left. And hence x minus 4 is equal to 15. So x is equal to 15 plus 4, that is 19 Newton. So the value of x is 19 Newton and the value of y is 5g Newton. Okay, so let us come to one more problem here. So again here a force diagram is given to you. This is an object whose mass is 3 kg. So obviously the force of 3g Newton will be acting downwards. Then there are forces which are acting in vertically upward direction. One force is of y Newton here. Another force is acting on this object and that is of 10 newtons. 10 Newton, that is acting downwards. Then a force of x Newton is acting towards the right, and a force of 7 Newton is acting towards the left, and it is given that the particle is accelerating vertically downwards at a rate of 2 meter per second square, and in this case also you have to find x and y. So let us consider the horizontal direction. Now horizontally there is no acceleration, that means again the forces are balanced, no resultant force. So total force towards the right x Newton should be balanced by total force towards the left. That means x should be equal to 7 Newton. Is that part clear to you? Because there is no resultant force. That means resultant force horizontally is 0. Forces are balanced. So total force towards the right is equal to total force towards the left. So x is equal to 7. Now let us consider the vertical direction. Vertically there is an acceleration of 2 meter per second square. That means there is an unbalanced force acting on this object, and this unbalanced force will act in which direction? Vertically downward. Okay, because the acceleration is downwards. Okay, so vertically the resultant force Fv is acting in the downward direction. Which means the resultant force will be total force downwards. Now, what are the downward forces acting here? One is 3g Newton and another is 10 Newton. So total force acting in downward direction is 3g plus 10 minus total force acting in the upward direction, and that is y. And by Newton's second law, this will be equal to m into a. So keep this step in mind, how to find out the resultant force. So resultant force will always act in the direction of the acceleration. So in this case, since the acceleration is downward, the total force downward should be greater than the total force upward. So the resultant force will be total force in the downward direction minus total force in the upward direction. That is 3g plus 10 in downward direction minus y in the upward direction, and that is equal to mass into acceleration, or 3g plus 10 minus y is equal to mass is 3, acceleration is 2. So 3g plus 10 minus y is equal to 6. Or that means y is equal to 3g plus 10 minus 6, which will come out to be, if you take g as 9.8 and plus 10 minus 6, that is plus 4, which is to 3 significant figures, 33.4 Newton.